Hey everybody, this is Clock and Modular Arithmetic. So this section is a strange little departure from all the other things we've been doing. It's just a different kind of thing, but it's stuff that's appears in standardized teaching tests and things. So it's an important thing for you to just sort of have in your pocket. Um, and it's just a little different than what we've been doing. So to start with, we use clock arithmetic all the time. You just don't realize it. When you get prescribed something that you have to take every 8 hours, you take the first pill at 7, you can use the clock to calculate when you're going to take the next pill. You can also figure out how to cook a turkey. Like I figure out how long to cook the turkey and put it in on Thanksgiving based on when we want to eat, and we work backwards. Um, all of those kinds of conversations that you're having are clock arithmetic. So what you can do is actually turn this into math problems. So if we think about 8 hours, we're going to take that pill. I want to, there's my pen again. I want to take that pill 8 hours after 7 o'clock. So 7 o'clock plus 8 more hours, if I look at my clock, would get me to 3, right? Because I start at 7. I'm going 1, 2, 3, 4, 5, 6, 7, 8. Okay, so 7 plus 8 on the clock is 3. 3 plus 8 more is 1, 2, 3, 4, 5, 6, 7, 8 is 11. And then we can keep going. When you see a mathematical symbol in a circle like this, that is going to indicate you're doing that operation on a 12-hour clock. This is a table for that clock arithmetic. So think about it this way. 12 o'clock plus an hour is 1 o'clock, plus 2 hours is 2 o'clock, plus 3 hours. 12 o'clock plus 12 more hours, 12 hours from noon is midnight, it's 12. Okay, 2 o'clock plus 10 hours gets you to 12. 2 o'clock plus 11 hours gets you almost there to 1 o'clock, and so on. So what happens here is we cycle through 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and then we cycle back. You know this, you've done it. Okay, so to compute, what we do is we think about, particularly for sums and products, we think about the math and we think about the remainders. When you add or subtract in a 12-hour clock, if you add or subtract 12, 12 acts like a 0, because 12 is just gets you all the way around the clock, as I make hand motions you can't see here, back to where 0 is. So if I take 1 p.m. and I add 12 to it, I get to 1 a.m., but I still get to 1. No, put that in a circle. All right, subtracting 12 does the same thing. There are lots of kinds of clocks, like we could make a 5-hour clock. However many hours are on the clock, subtracting or adding that number will act as a 0. So on a 5-hour clock, it's 5. On an 8-hour clock, it's 8. Okay? When we subtract in clock arithmetic, basically we consider it like turning back time. So if we think about 2 minus 9 on the clock, essentially what we're doing is thinking about the clock, and we're starting here at 2 o'clock, and we're going to go backwards 9 hours. So 9 hours before 2, it's 1, 12, 9, 11, 10, 9, 8, 7, 6, 2, 3, 4, 5, 6, 7, 8, 9. Okay, gets us to 5 p.m. So if we count counterclockwise, that's subtraction. Okay, that gets us 5. So we can write it this way as 2 minus 9 is x, but we also have to have the idea that if I had 9 hours and we added 5 more, that would get me to 2. They are inverse like that. Okay. The thing that is tricky is not so much multiplication, but division. So on clock division, you can only define division in terms of multiplication. It's weird, the idea of dividing 8 hours by 5. Like, it doesn't really mean anything. It only makes sense in context of multiplication. We're going to do a bunch of these. Multiplication, so when you're adding or subtracting, the one key to note here is you always start at the first number in your math problem when you're adding or you're subtracting. When you're multiplying, you always start at 12. Okay? This is going to work for division too, but you really have to rewrite it as multiplication to get division. So we'll talk about that. But so what happens in multiplication is the idea is 5 times 4 is 20, right? 20 hours from 12. So if we think about our clock, and we think about, here's the 12. I'm going to count 20 hours. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 20 hours from 12 is 8, okay? That's the answer. So what that means is I also know that if I did 8 divided by 5 on the clock, it would give me 4. Oh, I'm thinking about 4 and writing 5. 8 divided by 5 is 4. 8 divided by 4 would be 5. Division by 12 is not something we do, okay? It's just you don't divide by 12. It's not meaningful. There's no answer. So just in terms of what you're going to see here and what the answers are, that's one of the things that's going to go a little sideways here. All right, so let's try some of these. You try them. Let's see how they go. 8 plus 8 on the clock. So start at 8 o'clock and add 8 hours. Where do you get? You should get to 4. 4 minus 12. If you start at 4 o'clock and take off 12 hours, you should end up back at 12. 4 minus 4, you start at 4 o'clock and go back 4 hours, you get 12. And then 4 minus 8, start at 4, go back 8 hours, you get to 8. All right, that wasn't terrible. All right, let's do some others. 3 times 11. Well, let's think. 3 times 11 is 33. So one of the ways without actually counting all the way around the clock to do this is to think about taking away 12s. I can take away 2 groups of 12, 24, gets me to 9. Okay, so the answer here is going to be 9. So whatever is left at the end, when I can't take away any more 12s. We're going to do B over here on the side. For whatever reason, I didn't give myself very much space. So to do 3 divided by 5, I have to set it up so that I can think of it as multiplication. What happens is I take my 3, I'm going to leave it here, okay? And I'm going to think about 3 equals 5 times something, okay? So 5 times some number on the clock gets me to 3. So I have to think about my clock and where that would get me. So I want to start here at 12, and I want to get to 3 o'clock. Well, I can count 3 hours, 1 loop around. That doesn't really help me because I don't know what I'm multiplying by 5 there. That's not a multiple of 5. I can keep going though. So that's 12 hours, and then 3 more gets me to 15 hours, right? 5 times something is 15. 15 divided by 12 would get me a remainder of 3. So 5 times 3 is 15. That's going to be a 3. Okay? That's going to be 15. If I take 12 out of there, I get 3 left over. So that's going to be my answer. Let's do the same thing for 10 divided by 11. All right, 10, I'm going to rewrite it. Oops, I'm not going to rewrite it like that. I tried to write 11 first. 10 divided by 11. So I'm going to think about that as 10 equals 11 times something, okay? So I have to think about how many times I have to go around the clock. I'm going to start at 12, and I want to get over here to 10. So I'd get around once, that's 10 hours. It doesn't help me. 12, go around is 24, that doesn't really help me. 36, that doesn't help me. 48, no. 60, does 60 help me? 10 divided by 11. Well, wait, I didn't went too far, right? 10, 11 times 2 is 22, isn't it? 11 times 2 is 22. 22 minus 12 gets me 10. So that should be a 2. That means 10 divided by 11 is 2, okay? You can see how these are kind of tricky. There's not going to be too many of them rattling around on the test or anything. This is something you just take some practice. All right, and then let's try 10 divided by 7. Looking at my examples backwards. So I'm going to rewrite it. 10 equals 7 times something, okay? Gets me there. So I want to divide something and get, so I got to think about multiples of 12. 12, 24, 36, 48, 60. 60 would be, that would be a multiple of 12. I could get 10 hours past there. Yeah. So if I did 10 more than 60, I'd get 70. So 7 times 10 would be 70. 70 minus 60 would give me 10 left. That's my remainder of 10. So that's my answer. 10 divided by 7 on the clock is actually 10. I know, it's sort of crazy. You're just going to have to roll with it. You're going to be okay. This is a 5-hour clock. It works the same way, basically, as the 12-hour clock. We work forward and we work backwards. 5 is the additive identity. So if I did 3 plus 4, I'd start at 3 and go forward 4 hours. I would get to 2. If I did 2 minus 3, I'd start at 2 and go backwards 3 hours and get to 4. If I did 2 times 4, I start at the 5. 2 times 4 is 8, so 5, 6, 7, 8 gets me to 3 o'clock. Okay, we can do the division, all of it works. So that's clock arithmetic. Then we transition into this idea of modular arithmetic. Modular arithmetic is it's pretty similar to working in bases, but it is, again, just like bases were different than counting in regular numbers, counting in modular arithmetic is different than counting in bases. The difference in modular arithmetic and clock arithmetic is that there is a 0 as the first digit, and the largest digit is 1 less than what we call the modulo. Okay, clock arithmetic always starts with 1, right? There's no 0 on our clock. So if I have modulo 7, the digits are going to be 0 through 6. There are 7 digits. Then modulus is 7. I know this sounds insane. It's okay. So I'm going to make a table in modulo 5. In modulo 5, I have 0, 1, 2, 3, 4. What happens in a modulo is that you just keep counting. So 5, 6, 7, 8, 9. That didn't take too far over. 10, 12, 13, 14. I'm going to make myself a little space here. What happens is we make numbers that are congruent here. Oh, I moved it. Okay, when we talk about congruent, essentially what happens is anything in this column, any number in that column is congruent to 0. Any number in this column is congruent to 1. Any number in the 2 column is congruent to 2, and so on. We only have 5 spots in modulo 4, but we have to keep going if we have that value. So watch. 0 plus 0 is going to be 0. Oh, yellow's not going to help. 0 plus 1 is 1, 0 plus 2 is 2, 0 plus 3 is 3, 0 plus 4 is 4. 0 plus 1 is 1, 1 plus 1 is 2, 1 plus 2 is 3, 1 plus 3 is 4, 1 plus 4 is 5. I don't have a 5, but 5 is equivalent to 0. Okay, 2, 4. We know what 5 is. 2 plus 4 is 6. 6 is equivalent to 1. 3 plus 4 is 7. 7 is in the 2 column. It's equivalent to 2. And so on. Oops. Oh my gosh. 4, 0, 1, 2. 4 plus 4 is 8. That's in the 3 column, so it's equivalent to 3. Okay? We can do some definitions here. So A is congruent to B in modulo M is written as congruent with 3 lines. This means that when I divide by, if I divide them through, they have the same remainder in the modulo. So if I think about the mod 5 table, 6 is equivalent to 1 because 6 divided by 5 has a remainder of 1. 11 would also be equivalent to 1 because 5 divided by 11 is 2 remainder 1. So whatever the remainder is would work there. 11 would be congruent. 16, 21. Anything you divide by 5 and you have 1 left over is congruent to 1 in mod 5. You can make modulo classes for any system. The classes that we can make, basically when they're talking about classes, they're talking about columns. So that's a class, that's a class, that's a class, that's a class, that's a class. Any class is a set of numbers with the same remainder. In modulo 7, we have 7 classes. In mod 5, we have 5 classes, okay? All right, so this is how we just set this up. This is the same chart we just made. This class is all congruent to 3. This class is all congruent to 2. This class all congruent to 1. This class all congruent to 0. So let's see if we can figure this out. Determine which number, 0, 1, 2, or 3. Remember, those are the only answers we're in modular arithmetic. We're in mod 4, we have only 4 choices every time. What are they congruent to? I want to know where 62 would end up in my chart. So what I'm going to do is I'm going to divide by the mod. 62 divided by 4 is going to be 15 remainder 2. So it's going to be congruent to 2. 48 divided by 4 goes in evenly. It's 12 remainder 0. So 48 is going to be congruent to 0. See, it's not that bad. It's just a little weird. So let's evaluate all the following in mod 7. So first, let's make our class. And I usually like to go a row past 8. Okay. So 5 plus 4 I know is 9. Here's where 9 is. So this is equivalent to 1. 6 minus 2 is 4. 4 is one of the choices, so that works. 6 times 2 is 12. Where's the 12? The 12 is here. So it's equivalent to 4. All right? Yep. Let's figure out how to make the statement true. The way we do this is we can think in that mod, okay? So we're going to do mod 7 here. 1, 2, 3, 4, 5, 6, 7. So I can't, here's the problem, right? I have a 3 minus 5, but where's 3? Well, you can start in any place in that class. So what I'm going to do is I'm going to start somewhere in that class, just not here. I can't take away 5 from the top row. But I can start at 11 and count back 5. I go 1, 2, 3, over to the 7, 4, 5. So the answer there is going to be, oh, I shouldn't be counting to 7. Oh, yeah. I have too many places. I knew it would go wrong at some point. 6. I was looking at the 8 below. It got me all messed up. Still, I'm going to do 3 minus 5. So I'm going to line up with the 3. Phew, here it is. And I'm going to count back 5 to the 9, 2, 3, 4, 5. That gets me here. So the answer is 5. In mod 5, something minus 4 gets me 3. So I'm going to go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. I want to get, when I subtract away 4, I want to end up here at 3. Well, so to figure out the opposite operation, I can just go forward 4, right? 1, 2, 3, 4. On what column I am? I'm in column 2. So 2 minus 4 is 3. All right. Let's do mod 8. 5 minus something gets me 7. 0, 1, 2. Mod 8, I have up through 7, which is what I tried to use earlier. All right, I have my mod written out. 5 minus 7. 5 minus something. So I'm going to go to that column. I'm going to count back 1, 2, 3, 4, 5, 6. Well, it took me 6 to get to 7, so 5 minus 6 is congruent to 7. That's it. Okay. All right. Let us see what happens next. All right. We can solve for x in multiplication too. So what we do is we do some multiplication, we do some practice up through the number of digits we have, basically. I can do 4 times 0, 4 times 1, 4 times 2, 4 times 3, 4 times 4. I find those numbers and their equivalencies, and then I figure out what x has got to be. So 4 times something makes 3. What is the thing on this list that makes 3? It's that. So x has got to be 2 in mod 5. We're going to try this one in mod 8. So let's see how it works. We're going to do our multiplication chart first. So I'm going to do 4 times 0. Well, that's going to be 0. And that's still going to be equivalent to 0. I'm going to make my chart 0, 1, 2. 12, 13, 14, 15. Okay. 4 times 1 is going to get me 4. That's still going to be equivalent to 4. 4 times 2 gets me 8. That is equivalent to 0. 4 times 3 gets me 12. That's equivalent to 4. Do you see what's happening here? 4 times 5 gets me 20. 16, 17, 18, 19, 20. That's going to be equivalent to... Oh, I skipped one. That's going to be equivalent to 4. Because I forgot 4 times 4. I got all excited. Because 16 would be equivalent to 0. So there's a bunch of things that are equivalent to 0, right? There can be more than one answer. So the answers here, x could be 0. It could be 2. It could be 4. It could be 6. But it can't be anything after that. 4 times 6 is 24, right? 4 times 6 would be 24. 24, 15, 16, 17, 18, 19, 20, 1, 2, 3, 4, okay? Also equivalent to 0. Because I can go to 7 next, and then I'm out of digits. So these are the only choices here, okay? I have to, oh, no pen there. These are my answers. That's going to happen. All right, there's one more kind of thing to do from here. This is an application of the mod problems. So it's something like there's a pilot. He's scheduled to fly for 5 days and then rest for 3 days. Okay, so first what we do is we say fly, 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 fly. And then they're going to rest, rest, rest. And then they say to us, okay, today is the 2nd day of her rest shift. So I'm going to circle where we are. Okay, I'm also going to think about what mod I'm in. 1, 2, 0, 1, 2, 3, 4, 5, 6, 7. Okay, so I'm going from 0 to 7. That would be mod 8. Basically, the schedule is 8 days. Okay, so I want to know what's happening 60 days from today. Well, 60 days, if I did 60 divided by 8, I would get 7 remainder 4. So 4 days after the day I'm on today is rest, 2, 3, 4, fly. 90 days from where I am today, let's see, that's going to be 11 remainder 2, rest, fly. Okay, 240 days. 240 divided by 8 is just 30. That's got no remainder, so they're on a rest day. Was she flying 6 days ago? I don't know. Well, let's count backwards. 1, 2, 3, 4, 5, 6. The answer is yes. Was she flying 20 days ago? I can keep counting backwards. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. The answer is yes. All right, there is another one in here for you to try. Try it. Works the same way. Okay? This is worth the practice. You'll also see it in my math lab. If you have questions, you know what to do. I will see you in the module.